Hey Thinksters, and welcome to this video where I want to show you real quick the Python list copy method. And surprisingly, even advanced coders don't really understand the details of the copy method. But there are some surprising details, and so it seems to be very trivial. Like, for example, if you have, let's just start with an example. Say we have a list of 3 elements, 1, 2, 3, and now we want to copy this list. Okay, what can we do? Yeah, obviously we can simply call the copy method. Okay, so in its simplest form, it doesn't take an argument. It has this return value, new list with copied elements. Okay, so you see the list looks exactly the same. And let's check whether it's really a copy. So we create a new list, list2, and we call list copy. And now we change the original list. Say we append an element like 42 to the list, and we check the original list. Now we see a new element is at the original list, but the copied list, list2, still has like 3 elements. Okay, so our append method on the original list didn't change the new list, list2. Okay, so this is the behavior we would expect from copying a list. But in order to really understand the copy method, you need to understand the difference between a shallow and a deep copy. And I have created I've prepared an image for you. Okay, so what is a shallow copy of a list? This is basically, if you use the copy method, you create a shallow copy of the list. So say you have a list of 4 elements. This here at the top is the original list. And so in Python, as in many other programming languages such as Java and C++, everything is object-oriented. And object-oriented means that we have the list object itself. So this whole thing is one object. And we have different elements of this list. And the elements are not really elements within the list, but they are references to other objects in memory. Like, for example, this integer object 6, the integer object 7, integer object another list. So a list can even contain another list, of course, and a list can also contain string values like the string hello. And all of those are basically objects by itself. So we have like 5 objects here. We have this original list is one object. Then we have 4 objects, other objects in memory, and the list simply consists of pointers to the memory address where these objects reside. Okay, and if you copy the list, we create a new list object, and the list object also has some copies to those same objects in memory. You see, this is a shallow copy, therefore, because the objects themselves, the list elements themselves are not copied, but we just refer to the same object in memory. Therefore, it's called a shallow copy. And now, if you would change this object somehow, for example, we append an element to this list element, which is like a nested list. It's a list in a list. If we append one element here, then this will be seen by both lists, by the original list and by the copy, because we have not copied the element itself. So let's check this. Basically, here we have created a list 1, 2, 3. No, let's maybe we will have exactly the same example. So we have a list of say 2 values, 6, 7. Then we have another list 1, 2. And then we have a string. And now we create a copy, a shallow copy of this list. We store it in the variable list2, and we call copy. And now we see, so let's print list2. Both look the same, but they are copies. So let's, for example, append an element to the original list. We append the element 42. Now let's check the original list. Let's check the copied list. Okay, you see the original list has now a new element, but the copied list, it still has the old elements. But now something strange happens. If you change in the original list, you take element 2, which is this list here, this 1, 2 sublist. It's one element, yeah? Now we take this element and say we clear it. So we remove all elements from this list. Now let's print the original list. This is what we expect to happen, okay? So we have basically cleared the second list, this list element, this nested list in our original list. Now we would expect So like a naive coder would expect that this doesn't have any effect on our copied list. But this is actually wrong. Why? Because our copy operation performed a shallow copy. So as I've shown you here in this example, both refer to the same element in memory. So we have a copied list with so you can change the copied list and the changes will not be seen by the original list. But if you change the list element itself, like we did previously, then it will be seen by the copy itself, by the copy 2. And you can see it here, okay? So the copy 2 sees that we have cleared the nested list and we have removed all elements from it. Okay, so this is a very important distinction. So then you may ask, how can we create a, so what is it basically, how can we resolve this issue? And you can easily resolve this issue by creating a deep copy. Okay, and what is a deep copy? Here you see an example of the deep copy. In the deep copy, all the elements that can be changed, that are mutable, like this list, will be copied as well. Okay, so we have like this hierarchical copy that happens. So if we copy this original list, we don't only copy the references to all immutable data types such as integers and strings, but also the recursively we copy the list elements and the nested lists and the nested iterables. So in this case we have now 2 lists, and if you create a deep copy, then we can change this list without affecting the original list's list element. Okay, so a deep copy resolves the issue. So the question is, how can we create a deep copy? As it turns out, there's a function for this. Like you can import copy, and now we can create a list 3 and simply call copy.deepCopy, and it does the recursive. I mean, I could go into the recursive algorithm how to create such a copy. So you have to perform basically a shallow copy for all mutable elements, but for all immutable elements you have to go one step deeper and then recursively call the copy operation. So you can write a recursive copy function, but it doesn't. But I mean, why should you do this? Stand on the shoulders of giants. There's already a function for it, so just use it. It's also pretty efficient. Not as efficient as shallow copying, obviously, because you have to do more copy operations if you go deep into the hierarchy. But it's, I mean, as efficient as it can be, more efficient than your implementation would be if you just implemented it yourself. Okay. So our list 3 now we simply call copy.deepCopyList, and now we print list 3, and now it looks the same. But if we change now the second element again, say we append an element 999 to the list. Now we print list 3. Okay, we see our element was appended. Now let's check whether the element was appended to the original list as well. No. Okay, now you see this works. It's a deep copy. So this distinction is really critical to understand the copy operation, to really understand it. And you will, I mean, if you don't understand this and you don't understand the concept of object orientation, then you will have serious troubles in your code, because you will never find the issues. You will never find the bugs, basically, yeah? Because it's really difficult to see that if you change the object, then all references, like all other objects that refer to this object, will also see the change, obviously, and you won't know why this happens. So this, I mean, it can be the source of really nasty bugs. So you need to understand the difference between copy and deep copy. Okay, then before I leave, I just want to give you a few more ways to copy a list just for fun. So of course you can have say we have a list 1, 2, 3. So now one possibility to copy the list is just a copy operation, which you have already seen. But then there is also you can also use slicing. Yeah, so you can slice with default start and default end index, which means that you slice all the way from the left to the right, and doing it will create a new list. So basically a new list with basically a shallow copy again. And then you can also take a list as an argument to the list constructor itself. This will also create a copy of the list. And then you can even do some list comprehension if you want. Yeah, you can go over all elements in the list and simply print the element, put the element into the list. So this will also create a shallow copy of the list. Okay, so now I have copied the original list LST, so not X. But here, if you want to copy the list x, then you have to write x here. Okay, so this way you can create copies as well. I mean, all of them are valid ways. You can even do this. You can do unpacking. So you can create a new list, and then you unpack the values of the original list using the asterisk operator. Okay, so this will also work. And this is my preferred way, because you see it uses only 4 characters, and it's easily extendable. So you can like unpack the values of the list X, then you can unpack the values of list LST, and then you can even add some new elements like 42 and 99. So this way you can create arbitrarily complex lists in like one line. It's really simple. So you can create copies and then append some elements and with one call, and it's very concise and also very efficient. Like the asterisk operator is really a nice operator, and I would say most Python coders don't really know how it works, but it just takes all the values of an iterable and puts them into the other iterable where you use it, the unpacking operator, this asterisk operator. Just use it in front of any iterable and it will just unpack the values in the higher level iterable. Okay, thanks for listening to this video and see you in the next video. Bye.